There are many rules and laws in science, and many repercussions take place because of that. Today we are going to learn about one such rule called the Ohm's law, Ohm because of the scientist, and the rule is very simple. In an electrical circuit, the current that flows in the circuit depends upon the potential difference that you supply to it, provided the resistance of the conductor remains the same throughout, meaning thereby that the conductor physical conditions such as the temperature, the pressure on it or its dilution does not change. Now, what is a conductor? A conductor is one which has charge carriers that can flow freely in it. So, a metal is a good conductor, fluid electrolytes are good conductors. We are going to use that rule to find the resistance per centimeter of a wire using the wire as the conductor in question, and thereafter establish Ohm's law. Also try and see if this experiment can help us find the material property of specific resistance of the wire. In order to do that, we require some apparatus. The apparatus per se would be a battery eliminator, a key, a rheostat, an ammeter, a voltmeter, and the wire in question. What will be the principle of its working? As we have just said that it would be Ohm's law, and what would be pertaining to that? That supposing we say that the potential difference is proportional to the current flowing through it. So, V is equal to K I, and if we were to plot a graph between V and I, then the slope would be giving us the value of K. We can also put it this way, that the current flowing through the conductor can tell us how much of potential difference is across it, in which case we can say that the voltage developed or the potential difference developed across the conductor is proportional to the current flowing through it. So, V is proportional to I, or V is equal to I R. This R becomes the resistance of that conductor. It is primarily that which we are going to use here. We also know that for a conductor which is like a wire, the resistance depends upon the material, which is its specific resistance, length of the wire, and area of cross section, which we can show as A. Let us make use of all this knowledge and try and find the resistance of this wire first. But if we are looking at resistance per centimeter, the wire length that we choose should be known. So, in order to find an accurate value of wire length and place it in the circuit in that way, we need a ruler and connect one end of the wire to the terminal in question across the voltmeter and measure using a scale, make a kink at the length desired and place the wire in such a way that the kink is just outside the terminal. The reason being that the terminal material is a good conductor, and any length of wire which is thereafter, that means say this portion, is not going to be in the circuit. In order to revise our circuit and to understand the circuit clearly, we must remember that the ammeter should always be placed in series and the voltmeter should always be placed in parallel with the conductor across which we want the potential difference. What is the role that each of these plays here? K is well defined. This provides the potential difference to the circuit. Without this nothing would work. What does the key do? It allows you to choose when you want the current to flow in the circuit and when it should not. So, on and off device. Then this measures the current flowing. This is the variable resistance and it is going to allow us to change the value of current in the entire circuit. The current change here will develop different potential difference across this wire, which can be measured in this connection. So, let us do this experiment, set up an observation table. What do we require to do? So, first and foremost, we need to find the range of the meters, the least count of the 2 meters and the least count of the ruler. So, what do we have here? The ammeter, the range is from 0 to 1.5, that we can record. We can find the least count by determining the number of divisions between 0 and 1. If we see this carefully, there are 40 divisions. So, 1 upon 40 is my least count, which calculates to 0.025 amperes. Likewise, look at this voltmeter. The range is from 0 to 1.5 volts, and there are 40 divisions again between 0 and 1. So, my least count for this meter as well is 0.025 volts. Least count for the meter scale by which we measure the length of the resistance wire is 1 millimeter, and the length of the wire, as we had checked out, was 20 centimeters. Let us now start taking our readings. I switch on the eliminator, put the key in, and let us observe the reading in the ammeter. The ammeter reading is 5 divisions. We can take and record the reading in divisions and later multiply it by the least count to get the real value in amperes. The corresponding voltmeter reading, as we can see, is 10 divisions. We change the value of current in the circuit using the rheostat and observe that the ammeter reading is 8 divisions and the voltmeter reading is 18. I change again. Ammeter reading is 12 divisions and the voltmeter reading, as we see here, is 26 divisions. We take more readings like this. The ammeter reading is now 16 divisions and our corresponding voltmeter reading is 35 divisions. One more reading we can take here. In this way, we can take at least 5 readings. Minimum of 5 are required because we plan to plot a graph, and if you have to plot a graph, you should not have less than 5 readings, because a graph shows a variation between 2 physical quantities. You can plot a graph with as many number of readings, but it is pointless if you go beyond that also, because the variation will remain the same. So, the ammeter reading this time is 13 divisions and the voltmeter reading is 28 divisions. Having found this, you can set out to do the calculations. Let me just put this off. You can set to do the calculations. What calculations are required? The resistance of the wire, which you will get by 2 means. One, by dividing the value of voltage with current, and the second would be by using the graph. So, in both ways you can find the value of resistance. Then calculate the resistance per centimeter. We can calculate our value for resistance by dividing the voltmeter divisions by the ammeter, and approximately, if you see just by looking at the readings, this value comes out to be almost the same. When you plot a graph with these readings, you can take a mean value of the line. From the slope, you can find out the value for resistance as also resistance per centimeter by using the length that you had already taken earlier. You can then also use it to find the value for specific resistance, in which case you will require additional reading of the area of cross section. You can use a screw gauge for that. You can make more extensions to this experiment. You can use any electrolyte, find its resistance. Where can we go wrong in this experiment? One which you normally children make a mistake, and that is connecting the ammeter not in series. You have to have your ammeter in series, so that all the current flows through it, and the voltmeter should always be connected in parallel with the conductor. The current flows through the conductor. So, this is in parallel with that. So, this should always be taken into account. All your connections should be tight. You should have current not flowing endlessly in the circuit. You should use the circuit only as and when required. So, switch it off when you do not need it or you are not taking readings. These are some of the precautions which you need to take, and you will get good results. And what extensions can you do? How can you do more project work with this? You can find out how much of the resistance is there for a wire by using a crocodile clip instead of placing it here, taking a definite length. You can choose different lengths by keeping this wire end loose, connecting a crocodile clip to the other and connecting at different lengths, and therefore, putting that in the circuit. So, you can have a variation with that. So, there are many things that you can do with this experiment, finding area of cross section of a wire, finding out whether it is homogeneous or not. Homogeneous means that the entire wire is made up of the same material. You can find that out as well. You can have a selection from the market where the wire is not made out of the same material throughout, in which case your resistance per centimeter would change, and that should indicate that it is not as they are quoting it to be. So, these are some of the things that you can do with this simple apparatus in the lab, and I hope you can use it for more things and more work around your home also.